All right, so we return for part 2 of level 2 of my economic simulation, and I have made some notes. Oh, hold on, I have to reconnect my screen capture. It is stuck on an old screen. So how do I do this? That's not it. Weird. Source. Okay. What's going on? Yeah, for some reason it's still stuck. Super weird. What's going on? Properties. Window capture. Yeah, display capture. There we go. That is how it actually looks. Okay, so I was having a problem with the simulation not working when I was doing the Monte Carlo simulations, and I figured that the main issue there was the fact that there is this no window version of the simulation, which needs to be recompiled. It doesn't automatically recompile it when you change it, which doesn't make sense to me. I think it should recompile. But anyway, so that has to be manually triggered. So I'll just show how to do that here. It's under model and then create no window version. So when I click that button, then it compiles me a no window version. And so if I press the normal compile and run, it doesn't do that. And in fact, if I'm in the LSD editor with that compiled version and then I run parallel run, then it runs the no window version that was compiled whenever I last compile it. So if I haven't recompiled it since making changes, then it will be out of sync with whatever configuration I have here. And that was giving me this error with like output gap could not be found, because when it was trying to run, when it was trying to set the configuration here on the simulation, it was like, wait, there's no equation actually for the output gap, and then it would crash. So that was the one problem. There was another problem, which was that the output gap would go to an undefined situation. And that was, since this is defined as the natural log of two values, if either of these values goes to 0 for whatever reason, which we can have since there's these Cauchy distributed shocks, then the log of that value becomes undefined. So an undefined value in the subtraction will cause v0 to be undefined, and when it then writes that to the result of this output gap, then it stops, and the simulation will not continue with an undefined value. So what I've done to fix that is I've introduced this code here, and I'm not, that versed in C++, so I used ChatGPT to help me generate this code, and that works fine now. It just checks if the v0 is undefined, and if it is, it sets it to the max possible value, which actually doesn't really make sense now that I think about it. I thought it was because if you were dividing by 0 and that's the reason you get an undefined value, then you maybe want to set this to max. But now that I think about it, the output gap, it depends, right? If the potential GDP goes to 0, then the output gap will be infinitely large. No, I suppose it works. If in either case, if either one goes to 0, the output gap is infinite essentially. So that makes sense. So we'll just set it to the maximum possible value. There's no infinite value that can be stored in C++ as far as I know. So I just set it to the max possible value. Okay, what else? So that's that. And then the final thing I realized is that I need to delete old simulation results when I'm doing the Monte Carlo versions, because I had a feeling it was trying to import some old versions and then it didn't work because they were, So I've made some small changes to the notation here, just using y star instead of y superscript p to define my potential GDP. I think that's a little bit more standard to use these y star or the star variables for kind of neutral rates or potential values. So I think that's it. So we can run this and see what happens. So let me see. So, oops, didn't mean to do that. So here we have the LSD simulation. Let me open the other window. Oh, I should say there's this other issue with LSD, which is a bit confusing for me sometimes, which is that if you have if you compile multiple times, you'll open multiple versions of this window, and then it can be confusing, like which version am I working in. So I think it's a kind of good practice to close these when you want to recompile. So I'm going to recompile once more. And then it opens me this version with the correct thing, and then I can check my settings. Here I've saved it, set it so that the upper cap is not saved, and there's no plots, which doesn't really make sense. Actually, the Cauchy parameter doesn't need to be saved, doesn't need to have plots. That's fixed. It's not the distribution that this tracks, but the parameter that we put into the distribution. So I think that's it now. I'm going to save this. And this is now my standard version that I can do the Monte Carlo simulation with. So since in the level 1, we just did the regular simulation, which is the thing when if you have just one simulation run and then you press the play button essentially, and then you just get the simulation. And we have here GDP in white and potential GDP in this pink color. And then where's the output gap in yellow? For whatever reason, the output gap is still relatively small. Yeah, I guess as a percentage, these two things are not that far apart. So in any case, this is just one simulation run, and it depends a lot on the seed. So if I choose a different seed here, even just 2, and run it again, it looks different. So one thing we kind of want to do here is to run the simulation multiple times. And so you can do that by setting this to, 100, let's say, and then pressing play, but then it runs them all sequentially and doesn't save them, I think, per default. So what I want to do actually is I want to use the Monte Carlo parallel run method, which then also here it sort of automatically saves these files. In this case, I'm not generating a totals file, but I'm generating results files that get saved to the folder in which the simulation exists. And since I'm running this, it opens up a log window where you can see whether it's run correctly. So it ran on my 8 cores, 12 or 13 simulations each, so that in total it ran 100 simulations. And maybe I'll just show where these are in my in my folder. I have this LSD folder where there's this work directory where it has level 2 simulation, and then sim1 is the current. That's the name of the configuration. So you can have multiple configurations to compare the settings. And then here I have my 100 simulation runs. And so if I can manually select those files to analyze them here in LSD, or if I press add here, I can, from the last Monte Carlo experiment, from the last parallel runs of simulations, I can bring in the files automatically. I'm going to press OK. I want to choose my series. I want the average, the median, and the maximum and the minimum. And then I press OK. And now this actually takes longer than running the simulation, which is, I think, also true when you have a more complex simulation. The analysis is it takes a bit of time. but now this is working correctly. And so now what I want to compare perhaps is the median GDP with the median potential GDP, let's say, just to check that, for example, there's no systematic bias in my simulation. So you can see, yes, that's actually really nice and similar. Whereas if I, we can leave those in actually, but let me actually just show the average and the max and the min. And then we can see that they can deviate quite a lot because of this distribution that I've chosen. So yeah, so we can see the potential GDP minimum is much lower. The max is actually higher also for whatever reason. GDP itself shows much less variation. But this is just pure chance. If I chosen a different seed, it could be the other way around. And so really this is the max value of any simulation run. Yeah. The minimum and the maximum for the normal GDP, and then the average for the two. Hold on, potential GDP max. Oh, that's this one. And the white one is the average for regular GDP, and the yellow is potential GDP average. Yeah, so those two averages are diverging a bit. That's why I think the median is a bit better, because it shouldn't diverge as much compared to the average. Yeah, because the average depends on these outliers. Okay. Yeah, I think that's what I wanted to show, how you can do this kind of analysis here. Let's see. Yeah, I think that's it. I mean, one thing we could look at is like the output gap. Let's see, where's that? Since that's this kind of new thing that we're showing. So we can see this sort of goes from minus 2.5 to about 5.5. And this is roughly sort of, yeah, in percentage terms, the difference between GDP and potential GDP. So if the output gap is negative, that would mean that potential GDP is higher than real GDP. If the output gap is positive, that means real GDP is higher than potential GDP. And so in level 3 of the simulation, we'll add inflation, and then I guess in level 4, or maybe also in level 3, we'll add the impact that inflation then has on GDP. And then we can add a central bank as our first agent, which reacts to inflation by changing the interest rate. Oh, of course, we'll need to add the interest rate first. And then we can add the central bank as our first agent, making a decision about how to direct the interest rate in order to maintain inflation to some target. And I think then we'll need to also think about like what kind of feedback loops there are, like how long does it take for interest to impact inflation, or rather, yeah, what are the steps that actually, how does this propagate through the economy? And that's when it starts to get interesting and complicated, and the decisions you make about the how to structure these things then really start to matter. But yeah, I think that's all I wanted to show for now. This is the end of the level 2 simulation with the output gap being simulated, and we're getting closer to making an agent-based simulation. So thanks for watching, and yeah, see you in part